Dear students, today we will solve the third numerical from chapter number 4. This is from physics class 9. The question states that two weights are hanging from a meter rule at the position as shown in the given figure. If the rule is balanced at its center of gravity, Cg, find the unknown weight W. Dear student, this is the figure. Here, this is the first weight, which is 4 Newton. It is hanging from this ruler, and this ruler is balanced at CG, center of gravity, and its distance from the center of gravity is 30 centimeter. On the other side, there is another weight which is unknown, and we have to calculate how much is this weight. It is hanging on the left side, and it is at a distance of 40 centimeter from the center of gravity. We will have to calculate how much is the weight. Dear students, this 4 Newton force is acting downward, and it is also trying to rotate this direction like this one. And there is another force which is weight of something. It is unknown, and it is trying to anti-clockwise direction. And their distances from the center of gravity are given 30 centimeter and 40 centimeter, and we have to calculate this one. Dear students, this is a numerical from the principle of moments, which states that if a body is balanced, then the clockwise moment, this one, and the anti-clockwise moment, this one, they both will be equal. If we represent this force 4 Newton by F1, because there are two forces, so we represent this force F1, which is 4 Newton, and its moment arm, or the distance from the center of gravity, it is 30 centimeter. We represent this moment arm as L1, and this is equal to 30 centimeter. Another weight which is hanging with this meter rule, this is W, and let we say this weight W as F2, the second force which is acting on the left side, and we have to calculate. We will put question mark here, and its distance from the center of gravity is 40 centimeter, and we represent this distance as L2, and which is equal to 40 centimeter. Since the ruler is balanced, so clockwise torque you represents the clockwise torque as CWT. C stands for clock, W stands for wise, and T stands for torque. Clockwise torque is equal to anti-clockwise torque. A C W and T. Here A stands for anti, C stands for clockwise, clock, and W for wise, and T for torque. Anti-clockwise torque. Since this force is rotating this ruler in the clockwise direction, so the formula for torque, if I say this clockwise torque as tau 1 and this anti-clockwise torque as tau 2, and we know that the formula for torque is force multiplied by moment arm. Since this is tau 1, it's here we will use the force F1 and the moment arm L1. And here in the tau 2, we will use the force F2 and the moment arm L2. Now putting the values here in this equation, F2 is W. So in place of F2 we will put W, and we have to calculate this, and its moment arm is 40 centimeter. I write here 40, and here F1 is 4 Newton. I write here 4, and the moment arm is here, in this case it is 30 centimeter. So to calculate weight, I will divide this 120 by 40. 0 will be cancelled with this 0, and 4 threes are 12. So the weight is 3, and since the units of weight are Newton, we will write here 3 Newton. So the weight of this block, which is trying to rotate this ruler in the anti-clockwise direction, is 3 Newton. Dear students, here one thing I want to mention is that I have not converted this moment arm L1, which is 30 centimeter, and the moment arm L2, which is 40 centimeter, into SI units, that is meter, because here centimeters are cancelled with centimeters when I divide 30 with this 40, because both had the units of centimeters. They had been cancelled, and we are left with just Newton, which are the units of the force or the weight. If I repeat this question once again, there are two forces. One force is acting on the right side, and it is trying to move this ruler in the clockwise direction. I have represented this force by F1, and it is 4 Newton, and its distance from the center of gravity is 30 centimeter. I have represented with this L1. And the second force, which is on the left side and is trying to rotate this ruler in the anti-clockwise direction, it is represented by W, but here I will represent this by F2, and its distance from the center of gravity is represented by L2, which is 40 centimeter. According to the principle of moment, if a body is balanced, neither it is falling towards the right nor it is falling towards the left. So clockwise torque is equal to anti-clockwise torque. I have written clockwise torque on the right side because this 4 Newton force is trying to rotate this in the clockwise direction. To make them synchronize, I have written clockwise here on the right side and anti-clockwise torque on the left side. If I represent clockwise torque as tau1 and the anti-clockwise torque as tau2, and putting the values of torque, which is F multiplied by L, tau1 will be equal to F1 multiplied by L1, and tau2 will be equal to F2 multiplied by L2. Putting their values and simplifying them, we can get that the weight, which is unknown here, is equal to 330 Newton. 30 Newton. Thank you very much for watching this video.